I welcome all of you to this lecture on electrochemistry. We will be considering ICSE class 10 syllabus. Let's start with this electrochemistry chapter. Here we are given introduction regarding what is electrolysis, how does the word come from, that is the origin of the word, and how elements and compounds react to electrolysis. Okay, let's start. Electrolysis establishes a relation between chemical energy and electrical energy. We can say that electrical energy brings about some chemical change. Now, the word electrolysis is made up of two parts. One is electro and another is lysis. Electro meaning flow of electrons or electricity, and lysis meaning separation or breaking. That is, actually, when electrolysis occurs, compounds undergo cleavage to form new elements or compounds. Many substances allow electricity to pass through them. It has been found that all the substances allowing passage of electricity do not undergo chemical change. So there must be two varieties of compounds, elements. One of those allow electricity to pass through them and they do not undergo any change, and the other one undergo the change. Okay, let's illustrate this one. Most metallic elements like copper, aluminium, iron, and all alloys, whether they are in solid state or liquid state, that is molten state, they allow electricity to pass through them and they do not undergo any chemical change. Non-metals except graphite, that is an exception, like sulfur, phosphorus, they do not conduct electricity. Okay, therefore metals and alloys are called conductors and non-metals are called non-conductors. Okay, so we have two terms, one is conductor and another is non-conductor. The conduction of current by a conductor is due to the flow of electrons in a particular direction, and these electrons are called mobile electrons, whereas insulators do not have any mobile electrons. For this reason, they act as a non-conductor or insulator. Chemical compounds behave differently when an electric current is passed through them. Now, compounds can conduct electricity either in molten state or in their aqueous solution. And what happens in that case? The passage of electric current through copper chloride decomposes it to metallic copper and chlorine. So this is what happens. That means copper chloride is an electrolyte, and when electricity is passed through it, it separates its constituent ions, copper and chlorine, and copper is sent to cathode and chlorine is sent to anode. Chloride ion is sent to anode. Copper 2 plus ion is sent to cathode and chloride minus ion is sent to anode, and there they become free elements to get liberated at those electrodes. And non-electrolytes, on the other hand, do not undergo any change or when we try to make them undergo electrolysis. For example, sugar solution, we can take hydrogen chloride gas solution in benzene also. In that case, it will also not conduct electricity. Okay, so that particular reaction in which electricity brings about a chemical change is known as electrolysis. Now, we now have two types of conductors. One is metallic conductor and the other one is electrolytic conductor. And what is the difference between them? We have specifically taken here copper and copper sulfate as a representative substances of each one. Now, what is the basic difference between a metallic conductor and an electrolytic conductor? We will see 4 differences here. In metallic conductors, the flow of current consists of a stream of electrons going towards a particular electrode, and that electrode is the positive pole. So, electrons flow from negative pole to positive pole. So, we have an excess of electron at the positive pole, and cations goes to that positive pole to accept electrons, and that positive pole is called cathode, and the negative pole is called anode, where we have deficiency of electrons. Okay. Whereas in electrolytic conductor, we have 2 streams. In a metallic conductor, we had a single stream. Here we have 2 streams, one for the cations and another for the anions. Cation goes towards the cathode and anion goes towards the anode. Next, when I was discussing about this metallic conductor in point number 1, I illustrated it with positive pole and negative pole and coined the 2 terms cathode and anode with this, but you have to remember that for metallic conductor this cathode and anode conception is not there. It is only there in electrolytic conductors. Okay. Metallic conductivity is the property of metals and alloys, that is only metals and alloys. So, metallic conductivity, we have an exception with graphite, and electrolytic conductivity is the property of electrovalent compounds. They conduct electricity either in molten state or in solution state, either in molten state or in aqueous solution, whereas metallic conductors conduct electricity on a solid phase, or maybe in a liquid, or if we maintain them in a liquid phase, they will also conduct electricity. Okay. After passage of electricity, no change occurs for metallic conductors, but in electrolytic conductors a change occurs, and that change is chemical in nature. Now let's see the definitions and examples. Now, electrolysis is a process where a chemical compound undergoes decomposition in the presence of electrolytic current. That current must be DC in nature, and new compounds are formed. Electrolytes are compound which either in aqueous or in molten state allow electric current to pass through them, and as a consequence they undergo chemical change. Electrolytes can be exemplified as molten salts, solution of salts in water, solutions of acids and alkalis in water. Okay, this has been exemplified here as electrolytes that are acidic in nature, electrolytes that are basic in nature, and electrolytes that are salt in nature. All of them are electrolytes, but the capacity to conduct electricity varies from compound to compound. All compounds do not have the same capacity to conduct electricity through them, and for this reason we divide electrolytes into 2 parts. One is strong electrolyte and the other is weak electrolytes, and we have non-electrolytes also. Okay, we talked about non-electrolytes in a few minutes before. Non-electrolytes do not contain any ions, they contain only molecules. Examples of non-electrolytes, we have various examples of non-electrolytes here that you can see. It can be water, pure water, that is distilled water, alcohol, kerosene, carbon disulfide, CS2, cane sugar, benzene, glucose, urea. All these things are non-electrolytes, and this implies that they are non-ionic too. Okay, now we are here to understand the difference between electrolytes and weak electrolytes. Strong electrolytes and weak electrolytes. Strong electrolytes allow large amount of electricity to pass through them, and obviously weak electrolytes will allow small amount of electricity to pass through them. And if we attach a bulb, as a consequence the bulb will glow brightly for strong electrolytes and will glow dimly for weak electrolytes. Okay, strong electrolytes are good conductors of electricity and weak electrolytes are poor conductors of electricity. It comes as a corollary to our discussion. Now, third point, these are almost completely dissociated in diffused or aqueous state, but these weak electrolytes are not completely dissociated. Their degree of dissociation is low, and degree of dissociation for strong electrolytes is high. Now, in strong electrolyte, these ions, strong electrolyte solution contains ions that are almost free. Almost all the ions are free and mobile, whereas in weak electrolytes some ions are free and mobile. Examples of strong electrolytes, this I was talking a little earlier, 2-3 minutes earlier. There we mentioned that some acids can be strong electrolytes and some acids can be weak electrolytes. Strong electrolyte acids are hydrochloric acid. Instead of hydrogen chloride, I should say hydrochloric acid, because hydrogen chloride is a gas. Sulfuric acid, nitric acid, and of course they should be dilute in nature. Concentrated sulfuric acid is almost a non-conductor. And weak acids, we have carbonic acid, acetic acid, oxalic acids as weak acids. Okay, strong bases, sodium and potassium hydroxides in aqueous or molten state, whereas ammonium hydroxide, calcium hydroxide, these are the weak bases. Okay, now salts, we have sodium chloride, lead bromide in molten condition, copper chloride in aqueous condition, copper sulfate in aqueous condition. These are strong electrolytic salts, whereas ammonium carbonate and lead acetate are weak electrolytic salts. I hope I am able to convey the idea of strong and weak electrolytes and electrolysis to you. Now, acids, bases and salts as electrolyte, I will discuss it in next chapter. Thank you very much for watching.